So welcome back, dear students, in the lecture series of Strength of Material. Today topic is shear force and bending moment. In the last lecture, we have discussed about the sign convention which used to solve the numerical, and today we will be definitely see one numerical and understand this how to draw the shear force and bending moment diagram for given beam. So uh, let's first I introduce myself. Dr. Ishad Ahmad Khan, as Associate Professor, Department of Mechanical Engineering, Sagar Institute of Research and Technology, Bhopal. So this is a numerical where simply supported beam and the three load is uh, acting on the beam, and the distance is also mentioned, which is important to solve the shear force and bending moment diagram. So let's start solving this numerical. So because this is a simply supported beam, first we have to calculate the reaction at the end, and already notation is given A, B, C, D, and E. So let's see first find out the reaction at the support. So we have what we need to do the first you can take the moment of all the forces about any either of to support. So suppose here we are taken the summation of moment about A is equal to 0. So we have taken this B and the perpendicular distance from A, that is here 8. So RB into 8, because it is going anti-clockwise, so minus sign is taken. The next load is, yes, that what is the next load is 8, and the distance of this 8 from the A, that is 7. So 8 into 7 plus next load is 10, and 10 distance of 10 from A, that is 4. So 10 into 4 plus the next load is 5. 5 into distance, perpendicular distance from A is 2, and all will be with the positive sign except first one, because first is moving anti-clockwise and all are um, moving clockwise, and then equal to 0. And when we solve this, we will get the RB is equal to 13.25 Newton. So using second condition, all the force which is acting on vertical plane vertically, so equal to 0. So RA plus RB, then this 5, 10, and 8. So RB already know 13.25, so we can RA is equal to 9.75. And so we know RA and RB are known. So now let's proceed to calculate the shear force. So for calculating the shear force, that simple method, this is called a direct method. And in this method, what we are doing, we just take some this verticals line, the first one out away of the beam, that 0 0, but then next is 1 1 2 2 3 3. This where is the load acting, or either it is support or in between. So we have to draw this kind of line, and here we already drawn, so you can see, and reaction at support we are knowing. So it is very simple now to calculate the shear force at 1 1, and so that is all. So you can see at here we are representing a shear force by the symbol V. So V 0 0 means shear force at 0 0, because 0 0 is outside of the beam, so shear force is 0. And here in 1 1 section, V 1 1, you can see which load is coming under this section. Only RA, the value of RA is 9.75, and we know the sign convention. When the load acting from down to up, uh, in when load location is the left side from the section, so it must be positive. So it is 1 1 plus 9.75, and come to the second section is 2 2 location. So V 2 2, there is the same, there is no load between the first section and second section, so it will be the same, plus 9.75 Newton. And come to the third one. In third one, what happened, just this 5 kilonewton is also the new load. So you have to be considered. So previous you take as it is 9.75 and take the 5 Newton with the um, uh, by the using sign convention of the shear force. So here it is acting downward at the left side of the section, and we are considering now 3 section. So it will be 9.75 minus 5. So now it's become 4.75 Newton. Now come to the 4, it will be same as the value in the section 3. And let's come to the section 5. So in section 5, the previous value you can take directly, and if any new force is acting in that present section, so you consider with the sign convention of shear force. So that is also negative sign, so it will be minus. Now it has become minus 5.25 Newton. So let's see the next, at the next section it will be same, which is as at the section 5. So next considering the shear force at section 7. So shear force at section 7. So previous value you take the previous value we can take as it is, and the next, what is that next load is that new load. So that is 8 Newton. So 8 Newton is come with the minus sign because its location is the left side from up to down in the case of shear force. So you can see this should be minus sign. I forget, I think. So it should be minus sign. So this all 8 5.25 and 8 is become 13.25 Newton. And come to the 8, so it will be same as the shear force at the section 7 and section 8 both are the same. So you can keep this same value, and at the come same 9 section, so you can say this one is a plus, and this section 9 it is located downward to the upward, and it is a left side. So it will be positive value is 13.25, and if it is come 0, it means whatever you have solved at the different location of shear force value, it is correct one. So this is a simple method, direct method to find out the shear force at different location of the that beam. Okay, so let's calculate the bending moment. So first draw all that. So we have some positive value and some negative value. You can see. So here we have positive value. So this is a reference line of shear force, and positive value can take upward and negative value take the downward. So this way we can draw the shear force diagram. So this is shear force diagram for the given figure. Okay, so bending moment calculation, and bending moment MA, it is simply supported. So always the bending moment at support is 0 in case of simply supported, and in case of that you can see um, at the point C, next point is C, and the load is acting at point C is 9. That is you can see here that here. So C is it is acting 5, and that is 5. You can see here at the 5, the support at 9.75 and distance is 2, so that this become 19.5. So similarly at D, that this is support load, and distance of the support load is now become it's a 4, and next value is the 5 into 2, so it's become 29 Newton meter. And because this is this load support at a load trying to upward direction, that's why it is a positive, and this is this load 5 trying to move downward. You can see from here diagram, here we are calculating. So you can see this load from at point D. So D is 9.75, distance is 4. So let us see. Let's calculate it. So here the value is 29 kilonewton meter, and at point E at point E, we can calculate the same way and using the no, sign conventions of the bending moment. Similarly, at B, and at a point B, it is come 0. So what we have process follow, it is completely true. And this is a simple way and direct way method to calculate the shear force and bending moment at the given section of the beam. So this is a bending moment diagram. All values positive we can see. Okay, so just put all the respective value, and it is and draw the linear line to connect all the points. So we will get the bending moment diagram. So this example, you can by the help of this example, you can see this is the shear force. The first one is the load diagram, this is the shear force diagram, and this is a bending moment diagram. So in always we have to be keep all three diagram one by one. Okay, the first load, then shear force, and then bending moment diagram. This is arrangement for that. So hope you understood today concept of this is a direct method to find the shear force and bending moment in given beam. So thank you so much for listening this lecture.